This video is going to be on the definition of the derivative, and the solution is going to involve the squeeze theorem and the limit of a conjugate. The first thing we need to know is the limit as x approaches 0 for this special term sine x over x is equal to 1, and this is found using the squeeze theorem and deriving it from a unit circle. The second thing we need to know is the definition of the derivative equation given by f prime at x is equal to the limit as h approaches 0 of this term. So let's do an example. We're given a function f at x, and we're asked to evaluate it at f prime at 0. And we have to find f prime at 0 using the definition of the derivative. So here I have written down the definition of the derivative, and we're going to write it in terms of our given equation. So f prime at x is equal to the limit as h approaches 0. And this first term, f at x plus h, we just sub in x plus h wherever we see x in our equation. So our first term is going to be x plus h plus 1 plus sine of x plus h over 3. Our second term from the definition of the derivative equation is f at x. So we're going to subtract. F at x is just our given equation, since as you can see here, f at x. So we're just going to write in our equation, square root of x plus 1 plus sine of x over 3. And this whole thing is over h. So now that we have our equation in terms of the definition of the derivative, we're going to evaluate it at f prime at 0, which is what we're asked for. So that's going to be the limit as h approaches 0. And what we're going to do here is we're just going to sub in 0 for wherever we see x in our above equation. That leads us to have h plus 1 in this term, plus sine h over 3. And for our second term, we have square root of 1 plus sine 0. And now we can, over h. Now we are able to simplify a little bit. And this leaves us with, we can't do much with h, square root of h plus 1, so we're going to leave it. And likewise, with the sine h over 3 term, we can't do much. This stays the same. The square root of 1 is just 1, so we're going to have minus 1, and sine 0 is 0. So we're going to leave it as it is. This is all over h. So now that I've gotten rid of my x variable, I only have my h variable, and I want to determine this limit as h approaches 0. So I'm on the right track. Now I'm going to evaluate these limits, but when we're using the definition of the derivative to determine a derivative of a function at a certain point, we want a real value. We don't want infinity as our limit, as that doesn't tell us much. So the first thing I want to note here is that we see this sine h over 3 term. And as soon as you start to see sine in front of with a limit involved, you begin to try to get to this sine x over x special term. What that does is it really simplifies our limit, since we know that this special case of sine x over x is equal to 1. So that's what I'm going to focus on. I'm going to write our limits, and I'm going to separate them into separate terms and determine the limits of them separately, since we know that we can add limits separately and then add the results at the end. So I'm going to do the limit of square root of h plus 1, and I'm going to bring the negative 1 into this term also. I'm going to put that over h, and this is going to be one limit that I want to evaluate. The second limit that I want to evaluate is sine h over 3 over h. Okay, and so one thing that I wanted to talk about is this limit that I'm evaluating. So the reason I took the minus 1 into this limit instead of just doing minus 1 over h is that if you see, if I were to evaluate the limit without the minus 1, I have h squared root of h plus 1 over h. And that's as h approaches 0. I end up getting 1 over 0. And this is undefined, and this does not give us the solution that we want. So we want a real value solution. I know that from the limit of square roots, that I can rearrange this, and instead of getting a number divided by 0, I can get 0 over 0. Because I can work with 0 over 0 when it comes to limits, but I can't work with a number over 0. So what this value gives us is if you sub in 0, h equals 0 for this, you would get 0 over 0. And although it's not what we want, we can rearrange this equation using a conjugate. So if I multiply this by its conjugate, and the conjugate is just the same square root, but switch the signs. And what this term is h, it's just 1, so it's not really affecting the original equation, but it's just making it easier to work with. So this will give us the limit as h approaches 0 is going to equal to h plus 1 minus 1 over h times square root of h plus 1 plus 1. And so from the numerator, we see 1 minus 1 is just 0. And that leaves us with h over h times the square root of h plus 1 plus 1. That's for the limit as h approaches 0. Here we can cancel out the h's, and you're left with 1 over the square root of h plus 1 plus 1. Now we can evaluate the limit of this brand new equation. So let's just put that in to this next line. The limit as h approaches 0 for 1 over the square root of h plus 1 plus 1. We're going to add that to the limit as h approaches 0. And here we notice that we have a sine h over 3 over h. Now it's not exactly what we want. It doesn't follow the sine x over x condition that is equal to 1, the limit as x approaches 0. So we kind of want to get this. And how do we get this? So we would need h over 3 in the denominator. So I'm going to multiply by 1 over 3 at the top and 1 over 3 at the bottom. And what this does is it gives me 1 over 3 sine h over 3 divided by h over 3. And I can just bring this 1 over 3 term in front of the limit, since it's just a constant. And now I have sine x over x, or sine h over 3 over h over 3. We can now evaluate these limits as h approaches 0, since we have no issues with the results, and it also gives us a value that we want. So the limit as h approaches 0 for this first term is going to be 1 over square root of 1 plus 1, or 1 over 2. this is going to be added to this 1 over 3 term multiplied by the limit as h approaches 0 of the sine x over x, or sine h over 3 over h over 3, which is just 1. So now here we get our solution of f at 0 is equal to 1/2 plus 1 over 3, or 5 over 6. And here is our solution. And there you go.